Alrighty, friends. Let's go ahead and review. This is 5.1. Keep in mind you get to use your red card, so put on there anything that gives you trouble. On that 5.1 to 5.3 quiz, this is probably the thing that gave people the most trouble. So let's just go ahead. What do you do when you have some on the top and some on the bottom? You can think of it as subtracting or canceling. So if you wrote this out, it would be 1, 2, 3, 4, 5, 6 on the top and 2 on the bottom. And so what you're doing is you're getting rid of the ones that they have in common, and that leaves you with 4, which is easier to do by just saying 6 minus 2 equals 4. And then because there were more to begin with on the top, they end up on the top. So every time, even if it's embedded in a bigger, harder problem, that's what you're going to do in that scenario. Whereas here, when they're side by side, you end up adding the powers together. Oops. The only reason I add those first two is that they're both base x's. So again, this really means x times itself, and then x to the 6 means x times itself 1, 2, 3, 4, 5, 6 times. So what you're saying is together that makes x times itself 8 times. But the easier way to do that is to just go ahead and add the powers. The reason I didn't include this is that it has a different base. Keep in mind that anything to the 0 power is 1, and that got some of you stuck on the quiz also. So really this means x to the 8 times 1, which is just x to the 8. Okay, so two things are happening here. One, you have to distribute this power. Currently the 4 and the 5 are to the first power. When there's not a power, it's a first power. This power on the outside does not multiply by the 4 or the 5. It multiplies by their power. So I would end up with 4 to the negative 3 power over 5 to the negative 3 power. Now, it says right on here, and it's always true, that you can have no negative exponents in your answer. To get rid of a negative exponent, you cross the fraction bar. So this one on the top has to move into the bottom, and then it'll become 4 to the positive 3. And then this 5 to the negative 3 moves to the top, because crossing that fraction bar is going to be what turns the power positive. And then you have that pink chart that helps you figure out what numbers to powers are what. So 5 to the third is 125. 4 to the third is 64. So this is your best final answer. Okay, in this case, when you're bringing a power in from outside of the parentheses, it's just like distributing, but you're multiplying it by the powers on the inside. And so I end up with x to the 12. And you can only distribute a power on the outside to the inside if there's not addition and subtraction. Later in the chapter, we do some problems that have adding and subtracting inside the parentheses, and then you can't distribute a power on the outside. And we can talk about that when we get to that part. Okay, so this is kind of confusing, but anything that doesn't have a power is to the power of 1. In both of these things, the negative 7 is the base. So you would end up just taking the base and keeping it, but then adding the powers like we did when the base was just a letter. And then you could look on your chart and you would end up getting a negative 345 because negative 7 to the third power, these two negatives will cancel out, but then you have an extra negative. So you get a negative answer, and 343 is what you get if you look up 7 to the third power on that pink power chart. Okay, now they're going to get a little bit more advanced, and so you want to kind of slow down. Again, I like to write in a 1 for the power of anything that doesn't have a power, so that when I go to distribute, and again, I can distribute here because there's no addition or subtraction on this inside the parentheses part. So everything that had a power gets multiplied by a power of 3. So 3 to the first becomes 3 to the third, x to the third, and y to the 6th. And then when I'm done, I look at my power chart and find out that this is a 27. Now, one thing that I've said in class, and I said on the last review video, check your answers. I put this in your notes too. Make sure you have no negative powers, because if you do, you should move them across the fraction bar and make them positive. And you should have no repeat letters. So if you're done and your answer had X written more than once or Y written more than once, you're not done. So like this problem, X is written here and again here. I can't have it written two different places in my answer. So these are getting multiplied. And so I take it one letter at a time. Actually, what I would probably do is move this into the bottom. So this first thing, the x to the 4 stays on the top because it has a positive fraction, and the y to the 3 moves to the bottom, except that it's not negative anymore. It would be a positive 3 now. And then I'm multiplying by x to the 6, y. Neither one of them has to move, and since they're not over anything, it's like being over a 1. So now these two guys are next to each other. So x to the 4 and x to the 6, they're just sitting next to each other. So altogether I have 10 of them. And then for the y's, there's some on top and some on the bottom, and I can't have them repeated in my answer. So this one is to the first power. So if you look at these, there's 3 on the bottom and 1 on the top. That's a difference of 2, because 3 minus 1. And they'd end up in the bottom because that's where there were more to begin with. So the 1 on the top would cancel out 1 from the bottom, but leave with 2 extras. Okay, so here, this is just multiplied. So it's like this times this times this. They're all just multiplied. So the thing that needs to go away here is this z, because it's to the negative power. So I draw a fraction bar and move it down. So this first part stays y to the 4 times z to the second. We multiply by y to the third, and we move down that z and put it to the positive 5 power. Now these y's are next to each other, so they go ahead and combine by adding. So I have 7 of them all together. The z's, however, are above one another. So I have 2 on the top and 1 on the bottom. And, 5 on the bottom. So that's a difference of 3, because 5 minus 2 is 3. And those extras would end up on the bottom because that's where there were more. So that is like a bigger version of what we did in problem 1. It's just that it's embedded in a much more complicated problem, but it's the same concept. Okay, why did I do 8 before I did 7? Who knows? Let's take a look at 19. Wait, what am I doing? Number 9. Life is hard. Numbers are numbers like they have been since, I don't know, forever. So 15 over 10, you can divide out a 5. So you would reduce that fraction just like you have since elementary school. And so it would turn into 3 over 2. Then scooch over and take a look at the x's. Because there was no parentheses, so I didn't have to distribute. There was no negatives. I didn't have to move any powers. So here I have 6 on the top, 4 on the bottom. So that's going to leave me 2, because 6 minus 4 is 2. And the extras will be on the top because the bottom runs out first, and that's where the extras will be. And then I can look at my y's. And I have 2 on the top, 5 on the bottom. So the difference is 5 minus 2, so 3. And those extra 3 will end up on the bottom because that's where I had more to begin with. So that's that. Okay, so here I don't have parentheses, but I do have negatives. This one is going to move down, and this one is going to move up. So I don't like to do too many things at once because I lose track. So I'm just going to leave everything else for now. I'm going to move the f to the negative 5 up to the top and make it positive. On the bottom, I'm just leaving everything else for now. And the f to the negative 2 that was on top is moving into the bottom to become positive. Now I can treat it just like I did the previous problem, and I can look at one thing at a time. So if I look at the numbers, what goes into 10 and also into 18? Really, I can only divide out a 2. So I'll have a 5 on the top and a 9 on the bottom. Then I scoot over and take a look at the e's. 4 on the top and 1 on the bottom is a difference of 3, and they're going to be on the top because that's where more were to begin with. Then I scoot over to the f's. I have 5 on the top and 2 on the bottom, so that's a difference of 3. And they're going to go on the top because that's where there were more to begin with, those 3 extras. So then my final answer looks like this. And it's kind of weird that the 9's way over, but it's not wrong, just a fact. So that is probably the pickiest detail section And so I think people really need to take a look at that. If you had trouble with it, look back at your 5-1 notes. Anything you want to transfer onto your red card, do that. This was what we did 5-2 day 1. It's just this next section, only up to here. So let's take a little look at that. It says to rewrite it in standard form. Standard form, if you remind yourself, is going to be from high down to low by powers. So it's the highest power goes first. Think of it as the most powerful goes first. And then it goes on down from there. So it says to write it in standard form, and then it doesn't give you a spot to do that. I'm kind of annoyed by that. So I'll do it over here. So the standard form for this is going to be, and this is just a fancy way of writing y. Looking through here, the highest power of x is this 5. And so I rewrite it as negative 4x to the 5th. Then I look for the next highest power, and that's going to be this x to the x to the second. So I'm going to have my plus 7x to the second. Then my next highest power is just the plain x, and then last is my minus 2 called the constant. So it didn't give me any space to do that, but whatever, here goes. That is my standard form. Now degree is just your highest power. And so once it's in standard form, it should be that degree or that power of the first term. So in this case, it's a 5. That's going to play into end behavior. We only pay attention to whether it's even or odd. It's not asking us that. Leading coefficient, it'll be called like the LC usually. That's going to be the number out in front once it's in standard form. So that's going to be a negative 4. And again, when we get to end behavior, we'll pay attention to whether that's positive or negative. Constant is just the number at the end of the caboose. And in this case, it's a minus 2. And then to find f of negative 2 simply means that you're going to put in negative 2 for all the x's. And this was the one where the calculator is super important because the negatives and the powers can get really messy otherwise. So I'm just going through my standard form rule, and everywhere there was an x, I'm putting in negative 2 with parentheses, and then I'm putting whatever power the x had. So I would type that into my calculator, and I'm just stealing this answer from the key that was online because I don't have a calculator here somehow. So I'm hoping that's right. And then this is asking us just to do the same thing. So let's do that. Standard form, still annoyed that there's no place for that. Highest power here is going to be this power of 3. So it's going to be, and you take this whole thing, you take the number in front of it, which technically is negative 1. So the negative 1x cubed, then the next power of x is just a 2x, and then you have the plus 8. So this is going to be standard form. All right, my degree is going to be my highest power, so that is going to be a 3. My leading coefficient is going to be the number in front, and so that's actually a negative 1. Then it asks for the constant. The constant is the number because it's constantly that number. It's never going to change. It doesn't have a variable with it, so positive 8 or just 8. And then the last one asks me to plug in a negative 2. So here I put in a negative 2, and then actually I'm going to do it in standard form. Sorry. So I'm going to have a negative from the rule, then I'm going to plug in a negative 2 to the third, and I'm going by this right here. Then I add 2 from the rule, put in a negative 2, and then I add 8. So that turns into 12. And it's very confusing. There's a lot of negatives. So just write the formula exactly as it was and put the negative 2 in for the x's and do whatever was getting done to them in the formula. Okay, then we separated out and made this 5.2 day 2. And this was very big brain. This was very new and it's pre-calc and you really have to think. This uses your red card. If you don't feel confident, then you need to have that red card ready to go. I'm just going to put this smack dab in the middle because there's space. But the thing you have to kind of remind yourself is that it is actually not new thinking. It is just sort of new notation. This is right, left, and I hope you already know that this is the x-axis. It's just that now we call right x going to positive infinity, and left is notated as x going to negative infinity. As you know, this is up and down, and you also know it's the y-axis. So here y is going up towards positive infinity, and when you say something's going down, y is going to negative infinity. So in behavior, your only two possible answers are positive or negative infinity. So here, this is in standard form already. It's highest to lowest. What we look at is the degree. The degree is 3. Then you think through it. That's odd. That means that the left end is going to do the opposite of the right. Then you look at the leading coefficient. And the leading coefficient is -4. I don't care that it's 4. I only care that it's negative. Tells me the right end will go down. It only tells you about the right end. But since the right end is going down and the left end is doing the opposite, the left end of this graph would be going up. So then when I look here, I see that this is x going to negative infinity, and that matches the left end. So this is asking about the left end, which I just decided was going up, so I would use positive infinity. Then it asks here, as x goes to infinity, which is asking about the right end. And we already decided the right end is going down because of that negative leading coefficient. And so down is notated like this. Some of you wrote up and down on your quiz. You don't want to do that. You want to write positive or negative infinity. Same thinking through this last one. Here the degree is 4. 4 is even. So that's telling you that the left end will do the same as the right. Then I look at the leading coefficient. The leading coefficient is 6, which is positive. And that tells me that the right will go up. So the right is going up and the left is doing the same. So it's going up as well, which means both of these answers are going to be filled in with positive infinity because both ends are going up. Then, some of you really killed this and some of you really struggled. So let's take a look. What we need to do is we need to find the max and the min. And so you have to pay attention to where it is the highest and lowest. The maximum is like a peak and the minimum is a valley. Some of you wrote the random points. That's not okay. You want to pick the lowest point. That's a min. It's my dog gagging, so that's fun. Here's the max. Here's another minimum. So you can have more than one. This green pen is awful and you can't see it. So the maximum, we only have one, and it appears to be at 1, 8. That's an XY coordinate pair. How far over? 1. How far up? 1, 2, 3, 4, 5, 6, 7, 8. Okay. I like to draw a line down through it, and then I write just the x-axis or x-coordinate at the bottom. You don't have to do that, but it helps me. I have two minimums. One here, which is at negative 1, 2, 3, 4, 5, 6, and then up 1, 2, 3, 4, 5. So for that one, my x-coordinate is -6. And I'm focusing on the x-coordinates because that's all I get to use for my increasing and decreasing. The other minimum is this guy right here, which is over 1, 2, 3, 4, 5, up 2. So these are all xy's. But the only numbers I'm going to use in the increasing and decreasing are the x's from that. So I'm going to go ahead through this last minimum. And at the bottom, write the x coordinate of that. So those are x's only. keeping in mind that this left end is negative infinity and the right is positive. So this row is now the numbers I'm going to use for my increasing and decreasing. Increasing is going uphill from left to right. So if you look at this graph, it's going up from here and it's going up over here forever. So those two regions are here and here forever. So that is from, for increasing, here, which is -6, to here, which is +1. So this is where you go, it's from this x to this other x. That's how you write this. Then the second part is increasing from 5 to forever. So I write infinity. How about decreasing? Decreasing is going to be coming down from left to right. Now I know this arrow is pointing up, but I'm talking about from left to right. If you're riding your bike, you're going downhill and downhill. So this region and this region are decreasing. So this region on the far left goes from negative infinity to here. And this next pink part is from here to here, which is from an x value of 1 to an x value of 5. So I look back up here, 1, -6, and 5. Those are the only numbers I can use down here in addition to plus minus infinity. So that is what I did. Let's try one more time. So this has a high point here, so that is a max, and a low point here, so that is a min. I don't care about any other points on the graph. So that's increasing from left to right there and here. Let me draw in my points first. So my relative max is right here, and that's at -1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, up. And then my min right here is at -1, 2, 3, 4, up 2. So I only have those two, which means these two x values are the only numbers I'm going to be using for my increasing and decreasing. So this is located at an x of -6. This min is located at an x of -4. All the way to the left is negative infinity. All the way to the right is positive. So the two pink parts that I drew are increasing, and that's happening here and then from here on over. So that piece on the left is from negative infinity to -6 using these. And then the next piece is from -4 on forever to the right. So the only part of this graph that is decreasing is going to be this part right here. And that is just between -6 and -4. So this bottom row of x's are the only ones. Those are the only numbers I can use when I'm doing my increasing and decreasing. So let's stop there. That's a good chunk. That was what was on the quiz. And so 5.1, actually 5.3 was on the quiz also. But this is 5.1 through 5.2 day 2. So let's stop there, and then we'll tackle the back of it tomorrow so that we can really let it all sink in. Anything that I put on here, did on here, said on here that you want on your red card, make sure you put it on there because you're going to have that resource. It might as well be good. Thanks, guys. Bye.